Hello everyone. The title of this video is section 7.2 part 1 on adding and subtracting rational expressions with a common denominator. So in this video I'm going to be going over a version of the Knewton Alta assignment for section 7.2 part 1. Please understand that the version of this assignment that I'm going over, the questions that I will be seeing in this video, are not exactly, not necessarily going to be exactly the same as the questions you see when you go through this assignment on your own. But the objective will be the same, the types of questions will be very similar, and the way you go about doing them would also be very similar. All right. And also, whenever a new question pops up, pause the video and try working on that question yourself first before you see me doing it. Because if you're just watching me do it and not practicing yourself, you're probably not going to learn very much. All right. Okay, so here's the homework page, the assignment page. You're not going to see the words preview of. Right, you'll just see the title of the section and the mastery bar telling you how far along you've gotten in the section. The objectives, which it looks like there's only the one objective for this assignment. Then you have your questions, and at the bottom of every question there is a feedback button, which you can send feedback to Knewton through. You will not see the instructor cheat button. Right, this is only for instructors, but you will see a more instruction button, which I would recommend pressing if you are having trouble. This will provide you with further reading or videos that are related to the specific objective that you're working on, and hopefully those help. All right. So every question in this video will be on the objective add or subtract rational expressions, right, fractions, with a common denominator or with denominators that are opposites. Right, so they're the same denominator, but just times -1. One denominator will just be the opposite of the other. And that's what we have here. Right? So again, I'm going to write this out, talk about the steps I'll be going through, and we'll complete the problem. Okay, so here we're given a fraction minus another fraction. Now you have to remember that when you add, the only way to add or subtract fractions is when they have the same denominators. Right. So remember here, I'll write this in the upper right corner. You may only add or subtract fractions. That's getting kind of faint. I apologize. Right, so you may only add or subtract fractions when they have the same denominator or a common denominator. But that is key, right? Right. And this is only for adding and subtracting. All right, you saw in section 7.1, multiplication and division. When you multiplied and divided, you didn't need to get the fractions to have the same denominator. That was unnecessary. But when you add or subtract, the fractions must have the same denominator. And here's the rule for adding fractions. So say I have one fraction a over c, and then I add to it or subtract another fraction with the same denominator, b over c. See how they have the same denominator of c. Then when you add them together, that denominator that they share, that common denominator, that will be also the denominator of the sum. All you do is add the numerators to make the numerator of the sum. All right. And the same thing goes for minus, right? If it was a over c minus b over c, that common denominator would be the denominator of the difference, and you would just take the first numerator minus the second numerator, so a minus b for the numerator of the difference. So keep that rule in mind, but they must have the same denominator. Now, look at these denominators here. The first denominator, negative 4y plus 3. The second denominator, the denominator of the fraction being subtracted, is 4y minus 3. So right now, these are not the same. These fractions do not have the same denominator. So we have to do something about that. All right. Now the nice thing in this section is that if they're not the same, in this particular assignment, if they're not the same, they will be opposites. All right. And what I'm about to do is the same steps I'm going to do in section 7.2 part 2. I mean, I'll write them out again there. So first you're going to, when adding or subtracting fractions, if the denominators are not the same, like I have here, factor the denominators completely. I'll just say factor the denominators. That'll be the first thing. So here, first fraction, I have 12y squared plus 12y minus 7 in the numerator, right? I'm not touching the numerator yet. This denominator, negative 4y plus 3. If you recall, right, whenever the lead coefficient was negative, I would factor out a negative, the opposite of the greatest common factor. Well, the greatest common factor of these two terms would be 1, and because the lead coefficient is negative, I'm going to pull out negative 1. And if I factor negative 1 out of that, what I'll be left with is 4y minus 3. All right, so there's that denominator factored, minus, and then again, I'm not touching the numerators yet. Y plus 8 still the numerator of that second fraction. And the denominator, 4y minus 3, is as factored as it gets. And because it has multiple terms, I'll put parentheses around it, right? You really don't have to since it's the only factor, but I will. So now you can see that we're almost, right? These denominators are almost the same, but they're actually just opposites. Right? They're the same denominator, it's just one of them is multiplied by negative 1. Right? And when you multiply by negative 1, you get an opposite expression. Alright, so here's how we fix this. Very simply, take one of the fractions, and I'm going to multiply the entire numerator and denominator by negative 1. So negative 1 times the numerator, over, and then negative 1 times the denominator. Now you must multiply the numerator and denominator by the same thing, right? Because if you multiply just the numerator by something, you'll change the value entirely. Right, so we multiply the numerator and denominator by the same thing. That way it's like you're multiplying this fraction by 1. Right? Anything divided by itself is 1. And when you multiply by 1, you're not changing the value at all. So we'll get an equivalent expression, right? So the numerator, now I'm multiplying the entire numerator by -1. So every single term in that numerator gets multiplied by -1. So I have negative 12y squared minus 12y plus 7. And then multiplying the denominator by -1, well, let's see, you have -1 times this factor of -1, that makes +1. So that's the only reason I'm multiplying by -1 is so that -1 times -1 in the denominator becomes +1. And I'm left with just 4y minus 3, right? And since it's the only factor left, I don't really need parentheses around it. If you want to put parentheses around it, that's fine. Alright, so now I've changed the first fraction into an equivalent fraction with the denominator of 4y minus 3. Then we have minus, and then next fraction is, numerator is y plus 8 still. Denominator is 4y minus 3. Now I have what I want to start with when I'm adding or subtracting fractions. Now these fractions have the same denominator, or a common denominator. Alright. And if you were, so in this rule, the 4y minus 3 in the denominator, that's like the c's, all these c's. The negative 12y squared minus 12y plus 7, that's the a. And you have minus, and then the y plus 8 is the b. So when I take the difference, right, the denominator, right, that common denominator is the denominator of the difference. So I still write again 4y minus 3 in the denominator. It's the numerators that you're combining. All right, so be careful with subtraction. You're taking this first numerator, negative 12y squared minus 12y plus 7. You're taking all those terms and subtracting not just y, right? You're subtracting the entire second numerator. So I'm subtracting the quantity y plus 8, right? You're subtracting the y and the positive 8, right? So there's going to be some, when there's minus, you're distributing the negative to every term of that second numerator. All right, so keeping this going, I'm gonna simplify the numerator a bit. So we have, now there's no need for parentheses around this first numerator. We have negative 12y squared minus 12y plus 7. And again, we're subtracting every term from the second numerator. So minus y minus 8. All right, so there's the numerator, and we'll simplify that. We'll combine like terms in a second. And then we have, 4y minus 3 still in the denominator, that common denominator that we got. Combining like terms, well, we have negative 12y squared. There's no other y squared term. Negative 12y minus y is negative 13y. And 7 minus 8 is negative 1. All right, so there's the numerator polynomial. And again, the denominator polynomial is 4y minus 3. Now, after getting the same denominator, putting them together, and getting a single fraction, we must then simplify that fraction. Simplify the fraction. And you should know how to simplify fractions. Right? You factor the numerator completely, factor the denominator completely, and then cancel or divide out any common factors that the numerator and denominator have. Right, so I'm going to factor this numerator. Well, again, the lead coefficient is -1. So I'm going to factor out a -1. or you can just write a minus sign. Right. And then if I factor out negative 1, what's left over up here would be 12y squared plus 13y plus 1. Right. And that would factor to this, 12y plus 1 times y plus 1. Right. And I'll say simplify fraction, if possible, because it might not be simplified. It might already be as simplified as possible. So yeah, multiply these together, you'd get 12y squared plus 13y plus 1. Right? So there's the factors of the numerator, negative 1, 12y plus 1, y plus 1. And the denominator is just 4y minus 3, right? That doesn't factor any further. And since it's its own factor, it has multiple terms. I'll put parentheses around it. All right, well, I don't see any common factors. Negative 1, there's no negative 1 in the denominator. 12y plus 1 in the numerator, there's no factor of 12y plus 1 in the denominator. Y plus 1 in the numerator, there's no factor of y plus 1 in the denominator. So this is as simple as it gets. Or you could just type in this, right? This is what I'm going to end up typing. Right? So that original difference we were given, right, way back up here, this is equivalent to this fraction here for all values of y except 3/4. Right? Y can, I like doing this. You've seen me do this in other videos. I like to state the values that the variables can't be replaced with. Right? Y can't be 3/4 because you'd be dividing by 0. Right? You'd have denominators of 0 throughout the problem. But if you'd like to test it out, replace y with any number but 3/4, and the original difference should be exactly the same as this final fraction I got here. All right, and I leave it to you to test different values of y if you want. All right, but this is what I'm going to type in. I noticed after factoring that it doesn't simplify any further, so I can just leave it this way. Or you can write it in factored form. It should take it either way as long as you have an expression that's equivalent to what they want. Alright, so in the end here, now the numerator has multiple terms, so parentheses, negative 12y squared, then minus 13y, then minus 1, and then divided by, and the denominator has 4y minus 3. And this should be it. That's as simple as that will get. Alright, wonderful. But yeah, after getting a common denominator, right, after getting the fractions to have the same denominator, you're going to add them. And you see what they did. They pulled the factor of negative 1 out and just threw it in front of the fraction. Right? So because having a minus sign in front is like having a factor of negative 1 in front. Right? So that's what they did. But so again, and then after getting that common denominator, you combine the numerators, keeping the same denominator, and then you try to simplify that final fraction. Alright, now after every question, whether you get it right or wrong, there's an answer explanation. Please read through this, whether you got it right or wrong. Now if you got it right, read through it, make sure you got it right for the right reasons, or they may have done it in an alternate way that you didn't think about, and it'll give you just more tools for future problems. And if you got it wrong, definitely read through the answer explanation, see if you can figure out where you went wrong, and try to learn from your mistakes for future questions. All right. So the next question. Same objective, right? It's the same objective for all the questions. So once again, I'm going to write out this problem here whenever it pops up. Here it is. And once again, we have opposite denominators. See, one of them is 5w minus 7, and the other one is just negative 1 times 5w minus 7, or negative 5w plus 7. So this will be very similar to the first question. Right. All right. So once again, I'm noticing that now you could do the thing where you factor the denominators, but I'm noticing that these denominators are opposites. All right. If I just multiply this denominator by negative 1, I'd get this denominator. So they're opposites. So that's what I'm going to do. Multiply this denominator by -1. But remember, you can't just multiply the denominator of a fraction by something. You must also multiply the entire numerator of that same fraction by the same number. So I multiply the denominator by -1, and I also multiply the numerator by -1. And that should give me what I want to start adding. Right? I need to have the fractions with the same denominator. Alright, so this fraction here, when I multiply the numerator every term by -1, I'll have positive 15w squared minus 37w, and then plus 8. And the denominator will be 5w minus 7. Alright, then we have addition, right, plus. Then the second fraction, has the denominator I want, 5w minus 7. Both these fractions have the same denominator now. Alright, so now that the fractions have the same denominator, this is what I want. Right, I need the denominators to be the same. Right, now I can add them. And if you recall from the earlier question, the first question, when you add two fractions with the same denominator, that is going to be the denominator of the result. So I write 5w minus 7 in the denominator. And then I take the entire first numerator and we're going to add to it the entire second numerator now. Because this is addition, this is like having positive 1 here, there's no need for the parentheses. All we're doing is combining like terms, right? So the numerator has 15w squared. Then you have negative 37w plus 6w would be negative 31w. Then 8 plus 6 is positive 14. So there's the numerator. And the denominator is 5w minus 7. And now we try to simplify this, right? Try to simplify if you can, right? You saw in the first question that that fraction couldn't be simplified. Right? But this one I believe can be, right? You try factoring the numerator. Now, I'll leave it to you, but I'm not going to go into the details. I'm assuming you know how to factor by now. But if you were to take 15 times 14 and then find factors of that to add to negative 31, you could do that AC method or guessing and checking. But that'll factor to 5w minus 7 times 3w minus 2. And you can check this. That'd be 15w squared minus 10w minus 21w would be minus 31w, and then plus 14. That factors this way. And the denominator is 5w minus 7, right? And that's all one factor. If you want to put parentheses on it, that's fine. So do you see the common factor? All right, there's a common factor of 5w minus 7 in both the numerator and denominator. So I divide those to be 1. And all I'm left with now is 3w minus 2 in the numerator and 1 in the denominator. Now you can put over 1, but dividing by 1 doesn't mean anything. It doesn't change any values. So there we go. That original expression we were given has the same value as 3w minus 2 for any value of w except 7/5. Right? W couldn't be replaced by 7/5 because if you were to replace w with 7/5, the denominators throughout this problem would be 0. Right, but any other value but 7/5 you can plug in. Right, so if you went back to the original expression without all the writing and replaced w with 0, that sum and the final expression should both have a value of -2. If you replace w with 1, both the original sum and this final expression should have a value of 1, and so on. And I leave it to you to test other values of w, but this is what I'm entering, 3w minus 2. And that's it. All right. And again, please read through your answer explanations. So same objective, third question. Now this time, we're given an even easier problem, because if you look at these fractions I'm subtracting, they both have the same denominator already. They both have this denominator of 3d minus 6. So yeah, so these denominators for these fractions are already the same. They're already common. And that's what I want. Alright, so I can now put them together. And that common denominator will be the denominator of the difference. So I'm writing 3d minus 6 again in the denominator. And it's the numerators I'm combining. So I'm taking the first numerator, right, 3d squared minus 3d, and then subtracting every term from the second numerator. But there's only one term, so I can just write minus 6. All right. Now we factor. Right? Now we try to simplify this fraction. So the numerator has a common factor of 3. I'll pull that out. Then we have 3 times, d squared minus d minus 2. And the denominator has a common factor of 3 as well. Pull 3 out, and then you have d minus 2. And that d squared minus d minus 2 in the numerator, that'll factor further. So we have 3 times, and then d squared minus d minus 2 will factor to d minus 2 times d plus 1 over, and then 3 times, d minus 2. The denominator is completely factored. Looking at the factored forms of the numerator and denominator, I will now divide out common factors, right? The numerator has a common factor of 3, and so does the denominator. They have a common factor of d minus 2. So all I'm left with is d plus 1 in the numerator, and divided by 1 in the denominator. But again, there's no real reason to write divided by 1. So this original difference I was given will have the same value as d plus 1 for any value of d except positive 2. I can't replace d with 2, because if I do, I'll be dividing by 0 throughout the problem, and that's bad, right? That's undefined. But for anything else, right, if I replace d with 0, both these expressions should have a value of 1. If I replace d with 1, both these expressions should have a value of 2. And so on, right? And I leave it to you to check different values of d, but all I'm putting in at the end is d plus 1. And again, pay attention to the letters you're typing, right? Make sure it's the correct letter, not x plus 1, but d plus 1. And once again, read through your answer explanations. Alright, and this should be the final question. Alright, and once again, look at this. We're subtracting two fractions, but the fractions have the same denominator already. Alright, they're both 4c squared minus 1. So that should make this pretty easy to start. So once again, both these denominators in the fractions I'm subtracting here are the same already. So I can then subtract them, make them into a single fraction. And that common denominator is the denominator of the difference. I'm going to write 4c squared minus 1 again in the denominator. Alright, then the numerators get subtracted. So the first numerator, 2c squared plus 9c, minus every term. You'd be distributing the negative if there were multiple terms in the next numerator, but there aren't. There's just the one term, so it's just minus 5. Great, there's the difference. This is great. I just now wish to try and simplify this fraction if I can. All right. And to simplify a fraction, right, you factor the numerator and factor the denominator completely. Alright, so the numerator, 2c squared plus 9c minus 5. That would factor to 2c minus 1 times c plus 5. And I leave it to you to check, multiply this, you should get 2c squared plus 9c minus 5. The denominator, 4c squared minus 1, this is a difference of squares. That would factor to 2c minus 1 times 2c plus 1. And I'm hoping you can see the common factors in the numerator and denominator are these 2c minus 1s. Right? So what I'm left with is c plus 5 in the numerator, and since it's the only factor left, I don't need parentheses around it. Same thing with the denominator, there's only this one factor left, 2c plus 1, so I don't really need parentheses around it, and there we go. That's as simple as that fraction gets. So the value of this original expression should be the same as the value of this final expression for any value of c except negative 1/2 and positive 1/2. Right? Because if c were negative 1/2 or positive 1/2, these denominators would be 0 throughout the problem. Right? Except at the end, when c was positive 1/2, you'd be fine, but it's not good in the beginning. Right? When c is a half in the beginning, you'd be dividing by 0, so it's still not allowed. All right, but all I'm going to enter is this fraction here, c plus 5 over 2c plus 1. Now, since the numerator has multiple terms, I'm going to start by putting it in parentheses, right? c plus 5 divided by, and then 2c plus 1. And if you want to go back and erase the parentheses, that's fine, but this should be a good fraction here. All right. And once again, please read through your answer explanations. Okay, and that should be it for this version of this assignment. As I said at the top of the video, right, the questions I just saw aren't necessarily going to be the same questions you see when you work on the assignment. But the objective is the same. The kinds of questions you're working on are the same. The way you would go about doing them is the same or very similar. So I'm hoping that watching me go through this version of the assignment here helps you in some way when you're working on it on your own. And thank you very much for watching.